அனைவருக்கும் வணக்கம். Today we are discussed about the particle in a finite potential well. A particle in a finite potential well. ஒரு பார்ட்டிக்கல் ஒரு பொட்டன்ஷியல் வெல்லுக்குள்ளே இருக்கும்போது அதோடைய வேவ் ஃபங்க்ஷன் எப்படி இருக்கும், அதோடைய எனர்ஜி எப்படி இருக்கும் அப்படின்றத we have to find. Let us consider a one-dimensional finite square well potential box of length L. Our length வந்து L and the energy of the particle E, which is moving along x-axis, Here, if the energy is trapped particle, if less than the potential energy V, the potential barrier. Already உங்களுக்கு தெரியும், நம்ம barrier penetration பார்த்துருக்கோம். Here, the energy of V is greater than E. அதோடைய எனர்ஜியை விட பொட்டன்ஷியல் எனர்ஜி அதிகமாக இருந்துச்சுன்னா இந்த எலக்ட்ரான்ஸ் இந்த பார்ட்டிக்கிள் பெனட்ரேட் பண்ணி போக முடியாது. இப்போ எப்போ பெனட்ரேட் பண்ணி போக முடியும் அப்படின்னா, வெதர் இட் இஸ் the energy E is equal to V இருக்கலாம் ஆர் E is greater than V இருக்கலாம். Then only the particles penetrate through this potential barrier. Right? Here, according to the Schrodinger time independent wave equation, the region 1 and region 3, the region 1க்கும் region 3க்கும் Schrodinger wave equation எதுனா, ஆல்ரெடி உங்களுக்கு தெரியும், ஒன் டைமென்ஷனுக்கு d ஸ்கொயர் psi by dx ஸ்கொயர் ப்ளஸ் 2m by h cross ஸ்கொயர் into e minus v of psi is equal to 0. The energy V is greater than E. இங்கே வந்து V வந்து அதிகமாக இருக்குது. V is greater than E. So you can write the above equation d square psi by dx square plus minus, because here V is greater than E minus 2m by h cross square into V minus E of psi. V of psi is equal to 0. This is equation number 1. Let us consider 2m by h cross square into V minus E is equal to k square. Now we can write the above equation d square psi by dx square minus k square psi is equal to 0. This is equation number 2. Now the region 1 is region 1. The region 1 is 0க்கு இந்த பக்கம் இருக்கிறது region 1, இந்த Lக்கும் அந்த பக்கம் இருக்கிறது region 2. அதுதான் region 1 x is less than 0, region 2 3ன்றது x is greater than L. Now you can write the solution for the equation 2. Solution for equation 2, that is psi 1 is equal to a e power kx plus b e power minus kx. Region 1, this is equation number 3. Then psi 3 is equal to c e power kx plus t e power plus d e power minus kx. This is for region 3. This is equation number 4. Here A, B, C, D are called as arbitrary constants. Now the wave function at region 1, அப்படி wave function எப்படி இருக்கும், region 1ல wave functions எப்படி இருக்கும் அப்படின்றத ஃபைண்ட் பண்ண போகிறோம். wave function at region 1ல wave function எப்படி இருக்கும் பாருங்க. at x equal to minus infinity na the chance for finding the particle is 0. So psi 1 is equal to 0. The equation 3 becomes psi 1 equal to 0 means psi 1 0 equal to a e power minus infinity plus b e power plus infinity. Already know that 0 is equal to e power minus infinity equal to 0 plus e power infinity equal to 1 into b. So you can write b equal to 0 for the region 1. Now substituting this b value in equation 5 in 3 la போடுறோம். This is equation number 5. 3 la போட்டிங்கன்னா already you know that 3 na psi 1 equal to a e power kx plus b e power minus kx தான் 0 வச்சு. This is equation number 6. Next, wave function at region 3. Wave function at region 3. 3 la the wave function எப்படி இருக்குன்னு பார்க்கலாம். Here at x equal to plus infinity, here also the chance of finding the particle is 0. இங்கே வந்து particle எப்படி இருக்கும், 0வா இருக்கும். So psi 3 is equal to 0. Substituting equation 4 becomes, so psi 3 equal to 0 means 0 is equal to c e power plus infinity plus d e power minus infinity. Then 0 is equal to c power plus infinity equal to 1 plus e power minus infinity equal to 0. Then c is equal to 0. This is equation number 7. Now substituting equation 7 in 4 already know that psi 3 is equal to d e power minus kx. This is equation number 8. Here the equation 6 and 8 shows that the wave function at region 1 and 3. Now we have to find the wave function at region 2. Here a few probability for finding the particle outside of the region of 0 to L. However, the particle is finite, which is definitely the present in this particle, the region 1, that is 0 to L. So 0 க்கும் left side region 1லையும் எந்த பார்ட்டிகல் நம்ம ஃபைண்ட் பண்ணல, 0க்கும் அந்த பக்கம் Lக்கும் அந்த பக்கமும் region 3லையும் நம்ம எந்த பார்ட்டிகலையும் ஃபைண்ட் பண்ணல. But 0, that is V, potential energy V is equal to 0 means the particle penetrates through this potential box. So here we have to find some of the particle inside of the potential well, and the condition is E is greater than V. எனர்ஜி வந்து பொட்டன்ஷியல் எனர்ஜியை விட அதிகமாக இருந்துச்சுன்னா ஒரு பார்ட்டிகல் இந்த பாக்ஸ்குள்ளே பெனட்ரேட் பண்ணி போகும். Right. Here, according to the Schrodinger wave equation, you can write the region 2. Already know that the wave equation d square psi 2 by dx square plus 2m by h cross square into e minus v of psi is equal to 0. This is equation number 9. Here V equal to 0. Inside of the potential box, V equal to 0. Already know that V equal to 0 means you can write d square psi 2 by dx square plus 2m by h cross square into e psi is equal to 0. This is equation number 10. Now, the solution for the above equation is psi 2 is equal to f sine root 2m e by h cross x plus cos, that is g cos root 2 m e by h cross into x. This is equation number 11. The 11 represent the solution for equation 10. Here f and g are the arbitrary constants. Now you have to apply the boundary condition for region 2. The boundary condition in region 2, the boundary condition already know that x equal to 0 and x equal to L. We know that the wave functions will have the same value as at outside of the box. That is region 1 and region 3. Now the inside of the box potential energy V is equal to 0. The condition at x equal to 0 in region 2. X equal to 0 means you can write, already know that psi 1 is equal to psi 2, then d square, that is d psi 2 by dx is equal to d psi 1 by dx. Here x equal to 0 means the region 1 and 2 is equal. Now to find the value of psi 2 is equal to psi 1. Already know that the condition x equal to 0 and psi 2 is equal to psi 1. From equation 11 and 6. When applying the arbitrary condition x equal to 0 in equation 11, 6 நம்ம ஈக்குவேட் பண்ணுறோம் பாருங்க. ஈக்குவேஷன் 11 இது மேலே இருக்குது. தட் இஸ் psi 2 வேல்யூ என்னது? f sin root 2me by h cross into x equal to 0 plus g cos root 2me by h cross dx equal to 0, which is equal to equation number 6 a e power k x equal to 0. Now you simplify the above equations, that is sin 0 plus a cos 0 1 into g then e power 0 equal to 1, 1 into a equal to a. So here g is equal to a. This is equation number 12. Now to find d psi 2 by dx equal to d psi 1 by dx. Second one, to find d psi 2 is equal divided by dx is equal to d psi 1 by dx. Here the condition x equal to 0. Another one is d psi 2 by dx is equal to d psi 1 by dx. Now already know that the value of psi 1 from equation 6, differentiating equation 6 with respect to x, you will get d psi 1 by dx. Differentiate equation 6 with respect to x. Already know that equation 6 psi 1. Now differentiate equation 6 d psi 1 by dx equal to a e power kx into k. This is equation number 13. Equation number 13. Next, differentiate equation 11 with respect to x. Differentiate equation 11 with respect to x. Already know that equation 11, that is psi 2. Now differentiate equation 11, that is d psi 2 by dx is equal to f. அங்கே sin root 2m e by h cross இருக்கு. இதை நீங்கள் differentiate பண்ணால் cos root 2m e by h cross into x into root 2m e by h cross, then plus g cos 2m e by h cross இருக்கு. ஸோ அதை நீங்கள் டிஃப்ரென்ஷியேட் பண்ணால் மைனஸ் sin root 2m e by h cross into x into root 2m e by h cross. This is equation number 14. Now applying the boundary condition in equation 13 and 14, that is x equal to 0. X equal to 0. So you can write f cos root 2m e by h cross into x equal to 0, 0, then root 2m e by h cross minus g sin root 2m e by h cross into 0 into root 2m e by h cross. This is equal to, that is equation number 13, equal to 13 a e power kx இருக்குங்க இல்லையா, value of x equal to 0, so k0 into k. sin 0 is equal to 0, இந்த term ஃபுல்லாகவே 0 ஆகிடுது. ரிமைனிங் உள்ளது காஸ் வேல்யூ தான். cos 0 is equal to 1. So 1 into these values. f root 2me by h cross is equal to a k by e power 0 is equal to 1 into a k. This is equation number 15. Now substituting the value of a from equation 12 in 15. Equation 12 a equal to g a equal to g. So we can write the above equation 15 is f root 2me by h cross is equal to g k. Why? Because the equation 12 represent g is equal to a, g is equal to a, or a is equal to c. That is equation number 16. Or you can write f is equal to g k, this h cross equal to h cross divided by root 2me. This is equation number 17. Now substitute this value of other limit, that is x equal to 0 1, then another one is at x equal to L. Here the region 2 is equal to the wave function region 3, that is psi 2 is equal to psi 3, or you can write d psi 2 by dx equal to d psi 3 by dx. Here we have to find the psi 2 is equal to psi 3. To find psi 2 is equal to psi 3. Already you know the value of limits x equal to L. When x equal to L, you can write psi 2 is equal to 8 and 11 is, that is equation 11 is equal to equation 8. Now you can write equation 11, that is f sine root 2me by h cross into L, that is limit L is x equal to L, plus g cos root 2me by h cross into L is equal to d e power minus k L. This is equation number 17. Now substituting the value of f from equation 16 in equation 17. Already you know that equation 17 we have to find the value of f. The f is equal to gk h cross by 2me. So substituting these values, g k h cross by root 2 m e, then sine these values 2 m e by h cross into L plus g cos 2 m e by h cross into L is equal to d e power minus kl, or you can write g, we are taking outside, g into k h cross by root 2m e, then sine root 2m e h cross into L plus cos root 2m e by h cross into L is equal to d e power minus kl. From this equation we can find the value of d. We can write d is equal to e power, the e power minus kl இந்த பக்கம் வந்துச்சுனா plus kl, e power plus kl into g, then k h cross by root 2m e sin root 2m e by h cross into l plus cos root 2m e by h cross into l. This is equation number 17-18. Next one is we have to find d psi 2 by dx equal to d psi 3 by dx. இரண்டையும் ஃபைண்ட் பண்ண போகிறோம். Here also the value of x equal to L. The limit L தான் கண்டுபிடிக்கிறோம். L, that is differentiating equation 8 with respect to x. Differentiating equation 8 with respect to x. Already know the value of 8. What is the equation number 8? Now we know the value of equation 8, that is psi 3 is equal to d e power minus kx. d psi 3 by dx is equal to d e power minus kx into minus k. This is equation number 19. Equation number 19. Applying the boundary condition. Boundary condition already know that is x equal to L. In equation 14 and 19. Equation 14 and 19 x is equal to L into we have to apply. So you can write f cos root 2me by h cross into L into 2me root by h cross minus g cos, sorry minus na cos na sin, sin அங்கே cos இருக்கு, டிஃபரன்ஷியேட் பண்ணும்போது sin root 2me by h cross into L into 2me root by h cross is equal to this value equation 19 d e power minus kl into minus k. You can write the by equation f into root 2m e by h cross cos 2m e root by h cross into L minus g into root 2m e by h cross into sin root 2m e by h cross into L is equal to minus k, this minus k d e power minus kl. This is equation number 20. Now substituting the value of f, already we have to find f is equal to g k h cross by 2me. Substituting these values g k h cross by root 2m e into these values, root 2m e by h cross cos root 2m e by h cross into L minus G into root 2m e by h cross sin root 2m e by h cross into L is equal to minus k d e power minus kl, or you can write the above equation is g, we are taking outside, g into remaining k cos root 2m e by h cross into L. In the root 2m e, h cross cancel ஆயிடுச்சு. ஃபர்ஸ்ட் டேர்முக்கு, செகண்ட் டேர்முக்கு மட்டும் தான் இருக்குது. L minus இங்கே g taking outside, ஸோ ரிமைனிங் உள்ளது அப்படியே இது 2m e by h cross into sin root 2m e by h cross into L is equal to minus k d e power minus kl. This is equation number 21. Substituting equation 18 in equation 21. 18 in 21, we will get the value of quantized energy level in terms of the numericals or graphical methods. We know the value is, substituting equation 18 in 21. 18 already know that d values, so here substituting these values we can find this d values. Instead of we have substitute these values, we can find tan 2m e root 2m e by h cross L is equal to 2 root e into v minus e divided by 2e minus v. This is equation number 22. This is the value of differential form of psi 2x psi 2 d psi 2 by dx equal to d psi 3 by dx, that is region 2 is equal to region 3.